Good morning, everybody.
Good morning. Does anyone hear me?
I can hear you.
Yep.
Very good.
Morning.
Hey, Yoni.
Good afternoon.
Yeah, actually it is. Good evening to you.
Thanks.
One of these days, I'm actually gonna have to go Google what the correct salutation is for people in different time zones.
If you're from Texas, it's obvious. It's howdy.
That makes that easy. I was thinking more like, what is it? When they post rules of etiquette or something like that.
Hello, everyone. Today, Jeff could not be here and asked me to continue presenting the device identity provisioning and to continue reviewing and gather feedback on this work we've been writing here. Has anybody any other question? Otherwise, I can start share my screen and we can go over what we or go over the spec.
Go ahead, I guess.
All right, I'll start sharing. Please let me know when you can see the screen.
I see it.
Yeah, I see a browser.
Yes, the browser should should have this device identity provision spec sharing. Can you see it?
Fabrizio, can
Yes.
you try to make it
Yes.
bigger? Yeah. Well, maybe not as big.
Like this?
Yeah, that looks better.
All right, cool. So last time we identified a few odd issues on this spec, which we addressed last week. Some of those was about having the intermediate CA here, and we decided to remove it because we're just creating confusion and will be out of scope from the spec. So we have this individual vendor PKI right now without having the intermediate CA. Perhaps I need to be a little smaller, otherwise I cannot show the whole picture. And so we removed the intermediate CA. We just have the vendor PKI and operator PKI. Then we started identify the reason, the justification for this spec. Why we want to have a new operator, we call it this way, operator provisioning and endorsement of the device identity. Then we start putting together this into the spec. And there are few reasons why we want to do this. One of the reason is the one of the reasons is that if you have in a data center multiple PKIs, multiple devices, their own device identity will be signed by different PKIs, endorsed by different PKIs, and this will make difficult for relying party to be able to provide attestation service together, like to authenticate that evidence from different vendors. It means that we'll need to establish trust itself in multiple PKIs, and we'll need to have multiple trust anchors to be able to do that, which is possibly something that is not really convenient to have like tons of those trust anchor into the built-in into the relying party, to the verifier. So one of the reasons we want to do this and having an operator endorse PKI is to be able to verify, authenticate all the evidence with the same key, with the same operator PKI, which makes much more easier and straightforward to perform this authentication scalable across the whole fleet. So this was one of the first reasons. Let's say convenience. Second reason is that insulation from potential vendor PKI promise, like we discussed, we touched a bit last time. So what does this mean? It means that imagine that your vendor PKI at a certain point can get compromised because the operator doesn't control the vendor PKI. And that a time end could be compromised if this vendor PKI compromises out of control of the operator and perhaps could issue identity certificates that are not valid. So you will basically like cannot fully trust at any given time, like an operator, something you don't have control of. So what do? You endorse your operator PKI, you use the operator PKI to endorse your device identity. And I just want to mention this, like we touched also last time, like just to recap that the trust in the vendor PKI must be there at least once anyway, because once the operator receives the part, in order to establish trust into the device, there are no other trust vendor than the vendor PKI. But there is trusting once is different than saying I trust the whole time for my full lifetime of the usage of this product. So I could say I received the part as an operator, I received the part once, I trust the part once, and for the rest of the time, I will not continue to trust the vendor PKI because I will endorse it using I will endorse the device identity using my operator PKI, which I have full control of. And I'm not saying why we are endorsing, like the endorsing point, injection point can be a different stage. It doesn't need necessarily IDEV ID. but can be LDAV ID as well or FNC alias. But and I'm going over the reason why for a particular reason we put the LDAV, the injection point to the LDAV ID key pair in the next step. But I want to stop for a bit. You ask anyone any question at this point?
Yes. So Fabrizio, on the previous point you said, which is the convenience factor, and the exact verifier may not have all the trust anchors and stuff like that, right? And also this point you're making, essentially, my understanding is from an operator perspective, you would want to verify the identity and I mean, it may be identity, it may be alias certificate, it may be whatever the evidence of it. You will want to verify it at least once, for which you will have to have the trust anchor, you will have to know the CRL, all of that overhead is required at least once. Would you agree with that?
Yeah, yes, we say that once is doing perhaps a column, because you can do a column to do the vendor PKI verification, right? You can basically like, well, the column it means perhaps having a TLS connection with your vendor web portal and establish trust, like, and having perhaps a request from the vendor portal to establish this trust. But you don't want to get there all the time. You can do it once and then use your operator PKI, which probably you have local to your data center. You don't have to go always having a column to do this verification. I agree with you 100%. There's, like I mentioned here, the establishing the vendor PKI need to exist at least once, because otherwise all devices could make it up their device identity and you don't know where it actually comes from. So this has to be establishing. I agree, at least once.
Okay, thank you.
Any other questions up to this point? All right, I'm gonna move and I'm gonna explain about go over the third point. So this is really like targeting device like Calyptra, where delta ID is derived using the field entropy fuse. So the field entropy fuse is in-field programmable and allow decoupling from the device identity from the UDS. As people like, I assume everyone is familiar here with DICE. DICE starts with the first key, the DICE identity key is derived from the UDS, which is a unique device secret that is provided, provisioned in a certain fashion at manufacturing. And it is not given, we cannot given per se that the operator fully trust the manufacturing process of the vendor. If it doesn't fully trust the manufacturing process of the vendor, Calyptra introduces the field entropy here, which is a field programmed in field. It means the operator receives the part and start trusting the program the part and start basically generating a new entropy for key derivation of delta ID. That means that if the operator would endorse delta ID certificate after provisioning this fuse, will be able to completely decouple and exclude whatever was done at vendor manufacturing from their endorsement of device identity. Because the field entropy is not programmed at vendor manufacturing, so the operator could at this point remove from the trust boundary, exclude from the trust boundary what was done at vendor manufacturing. Like I say, I will not want to trust the vendor manufacturing process, which provisioned UDS might be compromised. That's fine. I give you an option to program this fuse, which is this field entropy fuse, and from now on, if you endorse this key derived by this fuse, from now on, you can have an attestation service signed by device identity which bypass basically this UDS coupling. And this is why, like in the previous diagram, we hinted that operator PKI would sign the LDEV ID certificate. And we were referring to the specific example from Calyptra. That being said, the LDEV ID is like there is no requirement for the LDEV ID to be derived this way. This is a choice the Calyptra product made to solve and to mitigate the potential not operator they don't want to fully trust the vendor PKI.
No, in that
The vendor
case,
manufacturing.
sorry, yeah. So in that case, right? So you have UDI and then the measurement of the next layer, combining to make the layer 0 identity, which is CDI, and then subsequently you are saying, okay, I can insert a field entropy at the LDEV ID layer, next layer. What is that arrow that says issues? I'm inclined to think that means certificate signature or the identity is derived from IDEV ID key pair. The private key of the IDEV ID layer issues the certificate for the LDEV ID layer. Is that not correct understanding?
Sorry, can you repeat the question? I probably didn't fully understand.
No, I think, Chandra, yeah, the issue is really what it means in practicality here is that it's signing the next layer certificate. You're correct, right? It means
Yeah.
issues the certificate for next layer, right?
Yes.
Which means
Yes.
signing.
So that issues arrow, right, from the IDEV ID key pair down, you have an arrow which says issues.
Yes. Oh, yeah.
IDEV ID key pair up one above, yes, that arrow. And also you have the LDEV ID operator PKI issuing a LDEV ID certificate. Also, it is coming to the same, layer in the certificate chain. So who is the actual issuer of the corresponding certificate? Is it the device IDEV ID, which is rooted in UDS, or is it the operator PKI, which is independent of the vendor?
You have two issuer of the certificate. You have two endorser for this certificate. You have IDEV ID endorser and you have the operator PKI endorser. And you can choose which one you want to retrieve when you do attestation.
Yeah, but how it really works is that, your IDEV ID certificate, right, at vendor PKI, you basically export CSR, right?
Mm-hmm.
And then sign it with your vendor PKI.
Yes.
So now this two IDEV ID certificate in this diagram, they have exact same public keys, right? So you can then follow the remaining of the chain.
I think the confusion is that IDEV ID certificate on the left top shouldn't be there.
IDEV ID certificate.
Right, the IDEV ID certificate only comes from the vendor PKI. There's no on-device generated IDEV ID cert.
Yeah,
That's
it's not
correct.
generated, but it's typically stored on the device. Yeah, but
Stored.
you're right, Matt. It's
Yeah. Stored is
a-
okay. Yeah, it's not generated on the device. That's correct.
Yeah, I think that's a little confusing to have that one there because like the LDEV ID, right? You either generate it on device issued by the IDEV ID or you generate it off device from the operator PKI, and they're two different certs and you can do whatever you want with them. They're distinct things. It's a little confusing to show the same IDEV ID cert twice.
Yeah, and also, thanks, Matt. That's a very good valid point. Fabrizio, the other question I have is, I mean, I kind of logically understand the flow, but are you, in a sense, separating certificate slots? I'm using the SPDM term certificate slot. Are you saying that the vendor PKI rooted IDEV ID certificate and that chain, which goes from there to LDEV ID to FMC to multiple layers of the implementation, that chain can be in conceptually in SPDM slot 0, and then the certificate chain routed in the operator PKI, starting with LDAV ID certificate and then goes down the chain, that can be located in SPDM slot 2. Is there like that type of although the same
Yes.
information may be there, same identities may be endorsed, but they exist in parallel? Is that a good understanding?
No, that's exactly correct. Like, yes, each certificate each endorsement will end up in a different SPDM slot, and this part of the spec, that's exactly where we're going to, like having a specific slot allocated for a specific purpose, and this is going to be part of the specification. We're going to be a little bit later, and also proposing a scheme for creating this discovery process for OCP, which will say, hey, which slot is assigned to what, basically.
Okay.
And yes, yeah, you are correct. You are going to correct the right direction where we were going. We are aligned on this one.
Okay.
So one other thing I wanted to mention is that another reason that with this, perhaps with this methodology, you can do what is called an implicit attestation. What does it mean? If you, in a specific case, like we are saying that you have the vendor PKI endorsing the LDAV ID at the manufacturing process, the operator PKI endorsing the LDAV ID certificate, then you can, for example, your tenant PKI endorsing the FNC alias certificate. Why this is another critical, I would say, like important aspect. Why could be very convenient to do this? Because the FNC alias certificate, as we clarified, and we also put like clarification at the bottom of the spec, Chandra, is that the FNC in Calyptra is not the first measure code, but is the first mutable code, and is derived using the first mutable code digest. Why is this allowing to do a sort of implicit attestation? Because it would allow to a verifier to be able to establish whether a firmware update which replaced the first mutable code happened, and in that case, this whole certificate chain will be invalidated. Like this authentication chain will break because this key will change if the first mutable code definitely changes. If that makes sense. So you will basically allow to do implicit attestation. It means detecting right away without having to actually verify manually if the FNC has actually changed by just authenticate the chain, because the chain will not authenticate anymore if after this endorsement this FNC will change, will be updated.
Okay. No, I understand. But so you are essentially devising two mechanisms to detect firmware update. There is measurements based as well as certificate based.
Yes, and this is just an implicit way to do it. Like that's why implicit attestation, because it doesn't require a verifier to manually do corroboration of the evidence, meaning like verify that whatever is in the whatever claim reported in the evidence matches with whatever you perhaps have in the column. Instead, it's like, okay, if this authentication will still be able to, in case you have a device identity endorsed from an injection point is the FNC alias certificate. If in the specific case of Calyptra, if by any case like an update happen and replace the FNC which was previously endorsed by your tenant PKI, you will be able to detect that without even using requiring the quorum, because it's like corroborating the actual measurement with the quorum.
So generally speaking, if you want that capability, you would want to certify the alias key pair, right? Because then you're offloading all the CORIM based validation to the tenant PKI. The way you have it here, the relying party still needs to verify any TCP info embedded in the alias cert.
In this way, in this one, like if the tenant PKI, like in this for the if you just want to detect if the FNC alias, if the FNC has been updated, you don't need to verify the TCP info because the certificate, the key of the certificate
The way you've drawn it, you only get that property for the FMC alias.
Yes,
It's not generally the thing that is signing assertions that the tenant cares about. Usually that would be the runtime alias.
Yeah, that's what I say. It could be the FNC, it could be the runtime alias. We can decide, like the next step, which certificate we will the tenant will care more. Yes, can be the FNC, but can be the runtime alias. The property I was describing was the detection property. More about I was able to detect that these the ingredient which are used for derive this particular certificate that I endorsed have changed.
Right. My point is the way you've drawn this tenant PKI chain, validate the relying party validating that attestation on the bottom still has to have a co-rim for the runtime.
Oh yes, I agree. Yes, I agree.
And so like if your goal is to offload processing of co-rims to a single place, that anchor point needs to be the bottom key pair.
Perhaps yes, I agree with you. Perhaps you are correct. The runtime alias will give you this one. However, there is another property here too into the, if you do not go to the specific case of Calypso, it's not just the FNC hash, but it's also the owner config. So the owner config has basically the owner key on it. So if the tenant wanna make sure that for example, the part has not been replaced and somehow the owner key has changed, for doing secure boot, they will be able to, he will be able to detect that only by endorsing the FNC certificate. He will not be able to do that with runtime alias certificate. But I agree with you, Matt. It's all a compromise. I mean, it all comes to what the actual tenants want to be able to detect. What we are describing here is that you are able to detect changes in the ingredient that are used to derive the key. But what ingredients actually matter to the tenant, yes, that's up to discussion. I totally agree with you. So that being said, there are any questions beside this? No other questions? So, okay. Now, like we said, we can, the spec will say there will be support for multiple PKI owners. There will be definitely the vendor root key, the operator root key, and the tenant root key. We are saying that issue the FNC certificate, but Matt, I get your point. Perhaps like for a tenant will be more interested to endorse a runtime alias certificate. We can revisit that. Let's keep it aside for a moment. But what we are saying that we have three different endorsement from the same attestation object. Like you can have an attestation object which is endorsed by the vendor root key, by the operator owner root key, or by the tenant root key. So you are able to decide at runtime which certificate, which attestation key you want to retrieve, which endorsement type you want to retrieve. And basically this could be happening like Chandra hinted before over SPDM, where these perhaps will be coming from slot 0, these perhaps can come from slot 2, and these perhaps can come from slot 3. And this is the scope of the specification, like we say, is discovering the set of identity keys supported by the device, along with the key pair respective derivation input. Establish trust in a select identity pair from the device, issuing and provisioning an identity certificate to the device, requesting a given identity certificate when obtaining an attestation statement from the device. And we say that is out of scope of this specification, discussing about certificate revocation and generic attestation verification.
Actually, I joined a little bit late. I'm just trying to understand. When we do the attestation of the runtime, the top layer, right? So basically in DICE, everything is linked together. So if FMC changes, the runtime attestation will fail. And when we the verifier is verifying the whole certificate chain, it will know which certificate didn't go through authentication step, right? So we'll
Yeah, correct. Go ahead. Sorry, I didn't mean to interrupt.
yeah. So
So no, but I don't understand. Do you have any? What's the question?
no, I don't. I'm just trying to recap whether I understood the discussion.
Oh yeah, yes. You say correctly. This is basically what is called implicit attestation. Implicit attestation, it means detecting something without having to directly verify the particular claim. Like, and this is like that's why we call it implicit attestation. It means like implicitly like something changes because this authentication chain broke, but you don't need to
Okay.
go and manually verify this.
Yeah. Basically, once you use the certificate chain verification, you know where the CDI chain, basically this whole DICE chain broke, basically, right?
Yes, exactly. And going into the next step, I wanted to bring here that we discussed previously that all these keys in SPDM can be identified with a key pair ID, right? And the CSI, to retrieve these keys and to certify this key, they will be processed over SPDM, where the owner, the tenant, or the operator in general could um, request from the device a get CSR. Get CSR means that I want to get CSR of these particular keys. I want to get CSR of Delta ID key. I want to get CSR of FNC alias key. I'm going to get CSR of the runtime alias key. But how to be doing that? Like SPDM 1.3 allow like identification of different keeper IDs and allow to do a get CSR of a specific keeper ID. However, these keeper ID are sequentially generated in order. There is no randomic. You cannot pre-allocate key 1 is used for this purpose or key 3 is used for this purpose. So what we decide to do, or we thought to do it, I believe it was part of one of the previous call, was to having a mechanism for discovering of this keeper ID. Like, for example, I want to know that keeper ID, SPDM keeper ID 2 is an FNC is correspondent for the FNC alias key. So, and how we doing that? We need a mechanism to discover those key and assign properties to those keys. Like properties could be, for example, LDEV ID key could be a properties derived from field entropy. FNC certificate may have two properties derived from first mutable code and derived from owner configuration, like owner key. Like we need to establish what are those properties. However, there is no real right now mechanism in SPDM to do the discovery of that. And one of the idea we had, and I put there, like in the last one of the previous OCP call, perhaps a few months ago, we had it, and I wanted to describe a potential solution right now with you is using a SPDM measurement block to perform the discovery. Like, let me rephrase this a bit more. The SPDM measurement block since 1.3, and by the way, 1.3 will be a pre-requirement for this mechanism to work because the concept of keeper ID started in DMTF SPDM from 1.3 version of the specification. SPDM keeper ID 1.3 also introduces this concept of structure manifest. The structure manifest of a measurement block can be assigned, can be connected to a CBOR tag, and that's how it worked, for example, for the connection, for whoever is familiar, for the TCG DICE concise evidence schema, which is basically a IANA register CBOR tag, which is which is identified, like which can be reported over a measurement block in the structure manifest. The same way, what I was describing here is having a mechanism like this, creating a new CDDL, which will allow, I don't know how anyone is familiar with this language. The CDDL is a seaboard data language that is used to describe seaboard data structure. For whoever is familiar with Corim, this specification is used in the this language, this syntax is used widely in the Corim for describing the data structure which make the commit or the other or the course width. So what I want to say is this data structure is identified with a tag, and we will need, in that case, we will need, the request will be for OCP to register a tag within the IANA registry, which is a registry which contains all the seaboard tags. And this tag will be associated to a data structure which contain a keeper ID and a list of attributes to be associated to this keeper ID. These attributes are OIDs, and the goal will be for OCP to assign attribute to those OIDs. For example, one OID attribute for this particular purpose will be telling, hey, this key is used or is derived use field ID is to field entropy. Or another one could tell you, hey, this is a mutable code. Another one, yes, it's a mutable code, but it's actually the first mutable code. Or another one, this key is derived using a owner key hash or something like that. So what this way, like this data structure, which will be associated, which will be basically retrieved by, and we will need to ask if it's possible to the NTF to associate, like give us reserve, allocate a measurement block for this purpose. So we requested in the past that this would have been done for it, and we say that that could have been possible using slot from F0 to FC. Now we want to probably use another slot, I don't know whether it's possible, to retrieve this data structure, which will provide this mapping between keeper ID and property associated to the keeper IDs. So that way, this will allow an operator to discover the keys and their properties and what CSR they will retrieve it. For example, this is the diagnostic version. This was just an example I put together of how this will look like. You will have two keys, a key 0 and a key 1. And you will have, like right now, for convenience, I use the same tag though ID, but assume here that you will have two different properties here, and these properties, OCP will document this property to a specific meaning. You say, hey, this property here means that is field entropy, and this other is derived with using the field entropy fuses. And this other property here will tell you that is derived, the key is derived with your reference certificate. Then your operator will be like, I really need this. I want to really endorse a key that is derived use the field entropy fuses. So what it's going to do, it will request over SPDM like a get CSR with keeper ID 0. Will that make sense? Any question?
Where are these properties being defined?
Very good question. These properties right now are not defined yet, and there will be part of the scope of this specification to define these properties and assign OIDs to specific properties. However,
follow-up question, is there a difference between these and what TCG has defined?
What is the TCG has defined? There are already
DICE defined a set of OIDs for conveying certificate properties. I'll dig up the link and send it to you.
Yes, that will be yes. If you can send to me, that will be Great. One couple of consideration. This is more than certificate properties as key properties. So how the key is derived, will tell you. And also, we will not limit. Definitely, this is a generic OID definition. Like there will be like this will not be restricted to. Like I mentioned here in this part, it's not be restricted. OCP will assign fewer attribute type, but this field is not restricted to those. What does it mean is that if you have like this will augment what TCG already been defined. Definitely we need to make sure not to duplicate what OCP TCG already been defined, but nobody will prevent to report here like attribute already defined by TCG if they make sense.
Yeah, we also have certain knowledge in the SPDM spec too. So TCG spec and the SPDM spec too define certain hardware OIDs and hardware identity OIDs and certain others too. Device ID OIDs.
Sorry, I'm not like there is some noise in background or something. I was not able to fully hear you, Sakul. Can you repeat the question?
Yeah. I was saying that we do have certain OIDs even in the SPDM spec for say device identity OIDs, object identifiers, as well as the TCG spec also has the OIDs. So is it similar to those?
Yeah, the OIDs is just the OIDs is just identifier, right? They could be identify different things. It's not specifically tied to OCP. It's not tied to TCG. Is not tied to any other spec itself. Like you can, like we mentioned here, you can use whatever OIDs makes sense to for defining the attribute for this key. If TCG defines some of those OIDs, if SPDM defines some of those OIDs, that's fine. What we are going to say that OCP will define something, some which will make sense for OCP. And naturally, when we define those OIDs, we'll need to be careful not to duplicate properties which perhaps are already defined by TCG or the NTF, but the combination of those, like will define properties for these keys. Like this particular data structure here that I put for attributes, it's identify a list, an array. What that means is that a specific key can be associated to a list of OIDs, not to a specific OID. So you can have an OID that say that this key is perhaps derived using some mutable code. Another OID that you see, oh, this key is derived using an owner key hash. So what that means is that you can have both OID assigned to this particular ID. Like you can have the combination of those will completely describe the key derivation.
Okay. So from an OID point of view, I think if my memory serves right, the TCG certificate profile specification and the DMTF main specification, they mainly talk about identity OIDs, both hardware identity or the more or less permanent identity, mutable identity, special use identity. All those identities are defined in the OIDs. But if you are talking about measurements and measurements themselves being identified through OIDs, maybe that is new and unique to OCP, right? Is that where you are going, Fabrizio?
Where we are going is to define OID to identify attribute for ingredient for the key derivation. That's where specifically we are going. I say how this key is being derived. Is derived use this key, is derived use this ingredient, whatever ingredient that we're saying. OCP can assign few of these attributes, but integrator vendors could be very creative on how they want to derive the key. So they might be require additional OID register for their specific purpose, which can augment what OCP will initiate here. It can be reported in this list.
Okay.
So could you summarize again how this information is going to be used? So the metadata that will allow association of key attributes with the keys, and in particular, those attributes will convey how the key has been derived. So who are the users of this?
The user of these are operator, tenant, whoever want to provide an endorsement of the device identity key and want to say which key they want to endorse. So what is the flow that is going to happen, which we will need to document here, will be for the operator to request this data structure, perhaps like from a specific SPDM measurement block, and we will need to request the MTF to assign one specific.
Fabrizio, but I think if you can go to the diagram of the certificate, yeah.
Okay.
It's basically to identify at which level you want to start endorsing the device certificate chain, right? As you can see here, there are 3 examples, right? You have vendor PKI that endorse at the IDEV ID level, but then you might have operator that wants to endorse at LDEV ID level, or you can have tenants that wants to only endorse at FMC level, right? So these attributes will help identify which level you're interested in.
It seems that the schema is a bit more complicated than just identifying at which level, right?
Yeah, it will. So it will have additional attributes there, but effectively how you want to use it is to identify this level, right? Each level can have multiple attributes, right? And this is just example of 3 that we think make most sense for, 90% of operations, but you can imagine that there are some additional key derivation schemes that might be custom for vendors, right? And they might want to have some additional attributes to identify this special scheme of derivation.
Okay, maybe let me try to describe how I understood what Fabrizio was describing, and maybe you can tell me if I'm wrong there, or maybe need some clarification. But it sounds to me that in order to issue a certificate by either operator or a tenant, you need a policy. You need to understand where the key pair in CSR is coming from, and how the private key is protected, ideally, and things like that. And this language of metadata associated with the key will help describe this policy to the issuer of the new certificate.
Yeah, you can think of it that way.
Yeah, that's correct.
So Fabrizio and Piotr, I'm looking at this a little differently. I thought the idea was that there needs to be a link to a key pair ID so that the endorser knows which CSR to request, thereby endorsing a particular level. And I thought the idea was that in the case like the tenant PKI, he's going to read a cert chain when he gets it. That cert chain is going to have different OID components like you were just describing in all the different certificates. They will describe the components of those keys that will allow the tenant, say, to bridge to a key pair ID and therefore a CSR and therefore an endorsement of its own. Am I just saying the same thing that you guys are saying?
Yeah.
Yes, I think it's the same. You're seeing from a different angle. You can see from an angle of level of the certificate or a level of the properties. At the end of the day, they will mean perhaps they will point to the same thing. The way we are describing in this specific data structure using attribute as your lens you were mentioning, but what we are actually doing is
which generate the OIDs.
Yes, which we are targeting a level. So we are saying the same things. And perhaps we can clarify this in the language of the description of this discovery process, that we are doing exactly the same thing, but how you want to see it, whether if you want to see from an attribute perspective or if you want to see it from a level perspective, is the same. And as Piotr mentioned, it makes sense. At the end of the day, you want to target a level, but the best way to target a level and be generic is to target properties, because this level might be level 2 in Calyptra, it might be level 4 with another implementer. But so the only way to be really generic, like be agnostic on a specific dice layout and target a specific key is to mention attributes, basically.
Yeah, I was being overly specific in terms of how actually to request the proper CSR, which you started the description saying that it's based on a key pair ID. And then I think you led into this idea of key pair IDs have these attributes associated with them. So my apologies, Dennis, for stomping on your question. I was just trying to bridge everything together to the ultimate goal of endorsing a particular level. So
Yeah.
thank you.
No, that's
Absolutely. That's completely fine. That's the kind of question that basically I need for everyone to clarify what we are doing. I appreciate that, Lance.
yeah. But Fabrizio, make a note here, right? That because people are asking this question, I think it's worth describing it
Yes.
a little better in the spec.
Yes, and honestly, and this discovery identity keeper process is still to fill in, and we just wrote the data structure. We just submit the data structure. Yes, so we will need to document this correctly, write the correct language that will take people away from ambiguity.
Okay. So this attributes will also consider things like how the key has been generated, whether you have used a puff or you're using the TRNG or what are the device platform configuration, those kind of stuff, or it is just very high level.
No, there is not an actual level you want to go it, whatever the specific property that you are using to derive the key. If you think that as a vendor it would be worth capturing as an OID, you might need, and you don't find already open industry like OCP already registered this OID for this specific property, you might need as a vendor to register this property and include into the discovery process, if I correctly understood your question.
Yeah, no, basically what I say whether you want to give more details how the key has been derived, because when you do the device key derivation, the CDI, right? We need take into consideration different parameter like UDS, platform configuration, whether you have what kind of security properties platform has, and all those things, right? Whether we go to that much details or it is just saying that we are using the platform configuration, or we have to go specify all the different things that we have taken as platform properties.
No, so yeah, I think Sanjay, that's the valid point, and I think we should consider adding those additional things, right? Like, did you use the fuse-based UDS or you use PAF, right? As an example, I think would be worth if you guys can provide feedback. What do you think might be of value to include in those attributes, right? So then we can decide what is the common set that we should drive in.
Fabrizio, I have a question. So today, if you do attestation, I mean, if you want to do it using SPDM, like you do a request, I mean, then you get the response, and then you use the RIM, right? The measurements are stored in RIM in order to, verify if the attestation is, successful or not. So why I'm still like struggling to understand, like, why would you need all these attributes if you can just indicate which slot your measurements are stored in your request? I mean, you can just put for the first level or whatever. I mean, the IDEV ID, you can store it in a slot, and then in an SPDM slot, and then for the LDEV ID in another slot, and then for the FMC in another slot, and then you can just indicate which slot you need in the SPDM request, and you're done. Why would we need?
Yeah, I think that was our original thinking. I don't know if you participated with some of the previous discussions, but that was our original thinking, to pre-allocate the slots. But as Fabrizio explained, it's making it not, flexible enough. And, different vendors might basically have different dice layout, right? Those layers might not be exactly the same for every single vendor, right? You might not have IDEV ID, then LDEV ID, then FMC. You might not have LDEV ID at all, right, in some devices. So we wanted to make it more flexible, but still allow to identify those levels for these key attributes instead of, hard coding it that, slot 1 is always LDEV ID or slot 2 is always FMC level. Right?
Okay. Yeah.
Is there a use case to control these?
To control what?
So like to say I'm thinking of a couple different potential control points. So one would maybe be, here's the field entropy I want you to use. And then is there also a use case to say, device, I need you to create a key at, a certain level and with these attributes, say with field entropy and
So
with
I
certain
don't.
fuse mix-ins.
So I don't think this is a mechanism to asking the device to create a key. It's a mechanism to discover a key which is already being created.
Yeah, definitely agreed for what you're showing, but is there a use case for that?
For creating keys?
For controlling this, yeah.
I think there would be a use case for like programming field entropy, certainly. The others, like all the other inputs would be configured by like loading a different FMC or runtime firmware image, for example.
Okay.
And that'll, we have PLDM updates for that. But
right.
It's just that field entropy that doesn't have a standard well-defined API for managing that yet.
Yeah, good point, Jeff.
And is there any proposal to bring that to SPDM, or is it going to be unique to OCP and remain with OCP? The programming of the field entropy. Or...
We've been
I'm not aware
discussing
of-
off and on.
Yeah. It seems reasonable to like anchor it or power it through like SPDM authorization.
Okay.
But I don't think we have any concrete proposal.
Got it. Yeah, that's what I was thinking. Thank you.
Thank you. Is there any other question, or I think we will be done, Jeff.
Cool. Thanks for leading the discussion. Yeah, sorry, I was not able to attend earlier.
No worries. Thank you, everyone.
Thank you.
Yep. Have a good day.
Bye-bye.
Thank you.
You too.